In this particular problem, we're dealing with exponential decay. Since the base of our exponent is a number that's less than 1, we're dealing with a decay. So right away we can eliminate the two answer choices that involve increased amounts because we know it's going to be decreasing. So right now you have a 1 in 3 chance of guessing correctly here. But let's go ahead and actually find the value. So if we want to determine the values for these expressions, given the t-value is the number of decades after 1900, well, during 1900, the t-value is going to be just 0. That's our initial value, so we'll plug in a 0 here, and we want to compare this to 1920. During 1920, our expression can be evaluated. 1920 is 2 decades since then, so our t-value is going to be a 2. And so we can just calculate these two values. So if we took anything to the 0 power is just a value of, or it's just a value of 1, so 500 times 1 just gives us 500. There's our population in 1900. And if we wanted to calculate in 1920, if we take 0.81 to the power of 2, multiply it by 500, we get our answer to be 328.05. And so if you compare these, you get a difference of 500 minus, we can use this exact amount. So our exact answer would be 171.95, which is closest to answer choice C. Now, if all you're going to do is approximate, since they are asking you which is about, or which of the following, it says by about in these answer choices, the way that we could look at this is, again, we'd still start with 500. That's easy to calculate by hand. But if you think of the 0.81 as a percent, so it's about 80%. Well, 80% is a fraction 4/5. You could make your comparison without using a calculator of 4/5 squared. Well, when you square 4, you get 16. When you square 5, you get 25. And so you could cancel. 25 goes into 500 20 times. 20 times 16 is 320. And so if you took the approximate value of 500 minus 320, you get your approximation of 180. So again, it confirms what we did with our calculator, but you can do it by hand with an approximation as well.